Hello students. So today in this class we are going to discuss the program slice. Okay, that is the way the in the last class we have defined about the DU path, DC path, etc. For do the program slicing or for testing the white box testing as part of the data flow testing. This is the second part of that particular method, which is called as the program slice. Okay, here that is. What is a program slice means? Program slice means this that is by focusing on the part of the interest where the variables gets affected. Okay. So when we say the program slicing a program means we are considering some interesting part of the set of statements as some interesting part of the set of statements which actually affects that particular variable, disregarding those parts which are not very interesting. That means the change of the variable, which the part of the statement or set of the statement which leads to the change of the variable is part of the slicing. Okay. So point of slice is to separate a program into components that have useful functional meaning. So those, when we separate the program into components that have some useful functional meaning, those particular part of the program is basically part of the slice. So for a particular variable, any variable, suppose variable x, those statements in the program which leads to the or contributes to the change of the values of the variable is the part of the program slice. Okay, and those part of the statements which does not contribute to the change of the values of that particular variable is disregarded. That is we are ignoring that particular part. Okay, so we cannot do this for DU path because DU path basically irrespective of the values of the variable, it will just take all the statements there. Okay, that is where from the first node defined where the variable is defined till where the variable is used. So we will taking all the statements. That is the DU path. So but here we will be basically considering those components which are of more interest than the others. Okay, so informally a program slice is a set of program statements that contribute to or affect the value of a variable at some point in a program. Okay, so basically it is the set of programs. It is informally we can say this is the definition of the program slice. That is it leads to the statements that contributes to the part of the statements which affects the values of the variable. Okay, at some point in the program. Now, if we go by the formal definition of the slicing, that is, it is given by a set as represented by S. Within that, we have the set of variables and the N. Now, set of variable means for those variables we are trying to do the slicing of the program. Statement that is the N nodes N means those statements which are affecting or contributing to the change of values of those variables. Okay, so it is basically the set of statements or set of nodes which are affecting a particular variable. But while representing, will be representing by the SVN. That is the statements which affects the values of the variable in the program. So usually the statement and the fragments correspond to the number of nodes in the program graph. So statement Vn is a set of node numbers. Okay, so this is a part of actually the backward slicing. Backward slicing means when we have a particular value in a particular statement, suppose some statement in the program say the 20. Okay, in the commission problem that we have discussed earlier, you have seen on the left hand side there are the statement numbers. So in this case we'll be considering those statement numbers as the node numbers. Okay, so till that particular point where a particular value is there, which has been a particular variable has taken a particular value, till that whatever statements have affected or contributed to the change of the values for that particular variable are part of the slice. Okay, so that is what the backward slicing means. Now basically this is called as the backward slicing. So backward slices refers to the statement fragments that contribute to the values of V at statement N. So given a particular value of a variable V in a particular statement, if we backtrack all the statements that has contributed to that particular value in that particular statement, then it's a backward slicing. Okay. Similarly, we can have a concept which is called as the forward slicing. Forward slicing means whatever the current value of a particular variable v, the other statements which are next to be followed from a particular statement, whatever values or variables it is affecting or contributing to, okay, those are the forward part of the forward slice. That is, forward slice refers to all program statements that are affected by the values of v and statement n. Okay, so value of v and statement n in a particular statement, whatever value the variable v is having, all other statements that are getting affected by that value is part of the forward slice. Okay, so that is the basic difference between static slicing and the backward slicing and the forward slicing. Now, inclusion of node n, whether to include a particular node n in the slice or not. Now, to include n, if variable v is defined at n, okay, now if the variable v is defined in a particular node n, then we should include that particular node in the as part of the slice. If the variable v is not defined in that particular node n, okay, only used, okay, then we don't have we will not use that particular node as the part of that particular slice. Okay, so that is what you must remember. So, but that definition means that defined here can be through input statement or can be through assignment statement also. Now, static and dynamic, there are two categories also apart from this backward and forward. One is called as the static, another is called as the dynamic. Now, static means whatever we have discussed in the last statement, that is the variables that gets affected, at the statement n, because of some, all the statements in the previous to it, they becomes, that is part of the static slicing. Okay, so independent, that is those, that consist of all the statements in a program that determines the values of variable v at statement n, independent of value used in the statement. So, if independent of the value that is being used in that particular statement n, all other statements which is contributing to the present value of that particular variable in that statement is called as the static slice. Okay. So there are two components you can see, static and dynamic. So when there is static, there must be also dynamic. Dynamic means execution time. So the variables which actually the value of the variable which gets affected in the execution time because of some parts of the variable set as vn, then that is the dynamic slice. Okay. So CUs and PUs are common way of identifying the statements. That is you see there is one defined part, another is the use part, right? Where we define part means where we define the variable v. The use part means where we use the variable v. Now, when you use the variable v, there are two common uses we have discussed in the earlier while that is the that is PUs and CUs in the earlier class. PUs means when the variable is part of the predicate statement. That means the decision making statements. When it is used in decision making, like in the say if statement, okay, so that becomes the PU. Similarly, in the while statement, it becomes the PUs. All other statements which are not part of the PUs, but where the variable is used, becomes the part of the CUs. That is computation use. So apart from that, in the case of program slice, we define some more terms here. So apart from that, there is the OUs, means where the variable is used in the output statement. LUs means where the variable is used for the location statement. That means where the variable is located, like pointers and all. Similarly, IUs means when the variable is used as part of the iterations. That means where it may be used as a part of indices in the iteration. Like, inside the while loop, you write I equal to I plus 1 to do the iterations, right? When the variable is that I variable, suppose you are talking about, then it is that is the iteration variable, okay? That is I use. The variable is used in iteration. So program slice can have two kind of definitions. One is IDEF, another is ADEF. IDEF means the input definition. That is where it is defined as the through input statement. When the particular variable is defined through input statement, it is IDEF. And when a particular variable is defined through assignment, suppose you are assigning some value to the variable, so you are defining that particular variable through assignment, so that becomes the ADEF. Okay, so you must remember this IDEF and ADEF and those other 5 statements there. One simplifying notation about slice is that a set V of variable consists of single variable V. So we will be considering initially we will be considering the set of variable V as a single variable, okay, to do the slicing. Initially we will take one variable at a time, okay. Extending this to the set of more variables is obviously you have to do it as you go on, because the values taken by variables are interlinked, okay. So first you take one variable and do the slicing, and then you go for taking more variables. So when you take more variables, then it is nothing but actually the union of those single variables. When suppose first you take one variable, do the slicing wherever it is defined and used, okay, by including the defined statements in the slice, but not using those use statements where it is only used, okay. Then take the union of these to make the slicing for 2 variables, okay, then go on that way. So the steps that is to be followed for doing this is like what to include in SVN, this particular slicing set, what needs to be included. So SVN, we consider single variable. So at a time, so for single variable slicing, let us see what to be included. So first include all the IDEF and ADEF, all the input def and the assignment def statements you include first for that particular variable. Then include the C use, P use of V, any computation use and the predicate use for the variable V, include those statements, okay. If excluding it changes the variable V. So if you exclude that particular variable, if that leads to the change of the variable V, the content of the variable V, then you must include those C use and B use statements of that particular variable in the slice. Remember this. That is, you are basically including on those statements only. First, see, defined statement you must include in the slice for a particular variable. Okay, variable in consideration here are the variables for which you are doing the slicing. Okay, so in the C use and P use statements are included where you have the only those statements where if you do not include it, it will lead to change in the values of the variable. Only those statements needs to be included. Okay, so those statements needs to be included. Then you can basically L use, as you can say, location use and the iteration use. This is before this there is this statement. If any other variable, if you do not include those statements, it leads to the change of the variable you are concerned with. Suppose you are doing it for the variable X. You are trying to find out the slicing for variable X. Now, for some other variable Y, if you do not include the C use and the P use of those, those statements of the other variable Y, and that leads to the change of the values of the variable X, then you must include those statements in the slice. If it does not affect the variable X, then you need to exclude it. Those statements which belongs to the variable Y. Okay, so this is what is included. So L means the location use, I means the iteration use. So location use and iteration use, whether you to include those statements in the slice, is basically judgmental. You may decide to include those statements or you may not decide. It is the judgment of the tester. Okay. So exclude the non-executable notes such as the variable declaration if a slice is not to be compliable. So if there is, you know, it is part, non-executable notes such as the variable declaration where you are declaring the declaration of the variables are there, you need to include those from the slice. Okay. So exclude the O use, that is output use, the output statements can be excluded. So what you need to exclude? The L use, O use, I use, okay, non-executable statements like, you know, declaration, etc. So L use and I use are actually judgmental. The tester can decide whether to include or not. You need to include all the defined statements, idef or adef, whatever it is there for the variable in the slice. You need to include only those PUs and CUs of the variable which leads to the change of the variable, the values of the variable. Whether other variables as far as is concerned, those statements which leads to the change of the variable of concern for which you are doing the slicing will have to be included, even if those variables are basically the other variables which leads to the change of the values of this variable for which you are doing the slicing. Those statements has to be included. So these are what you need to include in the program slice. Now let us see by taking a small part of the commission problem and the slice. Okay. Now slice, as we are telling about, see these are the statement 13 to 20 of the commission problem. So here we are basically taking the logs as the input and we are calculating the total number of logs, total number of stocks, total number of barrels which are sold by the salesman in the commission problem. Okay. So, so here, while not logs is equal to -1, the loops will keep on iterating, right? So, for the logs, slices on the variable log. So, where are the logs used? Logs are used in the statement number 13, statement number 14, right? And statement 16, statement 19, obviously 20 because 20 is the end while. So it is the part of the repetition. So we are using it in the 13, 14, 16, 19, 20. Okay. So while doing this slicing for the logs, we are basically ignoring 15, 17, 18 because 15, 17, 18 does not have any role in changing the values of the variable log. Okay. Now first slice is in the statement number 13 where you are taking the input. Okay. So input logs, yes, that is the slice logs 13. You have only 13 because this is the input statement and it is not part of any loop. So you are basically taking only this statement, input statement, and that is the only statement in the slice. Okay. Because you include, as the previous definition I told you, that is you include all the idef and adef statement. Okay. If there is no other use statement, you have to ignore it. Now logs 14, the statement number 14, that is the node 14, and the variable is log. So what is the slice set derived from this log? This particular statement is 13 because you are talking about log. So log is defined that input statement has to be included as part of that particular procedure. So 13, then the 14 where the condition is being checked, the logs is checked, right, with that particular statement, and then 19 and 20. So 13, 14, 19, 20. Why not 16 using? Since 16 log is used. But as I was telling you in the previous condition here, there is the number 2. Include any CUs and PUs in B if excluding it would change the values of variable. Only if the excluding of that particular variable or statement actually leads to change of the values, then only we need to include it. If it is not changing the value, we need not include it. So given this condition, you see the number 16, the logs is used on the right hand side. It is not going to change the value of the log variable. It is changing the value of another variable, total logs. So we need not use this particular statement in the slice. Okay. So similarly, logs in 16 is part of the loop. So it is again 13, 14, 19, 20. So 13 is the defined statement, right? It is the input defined. 14 is the loop condition where you are checking, is the predicate use, right? So 19 is again a defined statement. Defined statement we need to include, right? And then 20. 20 is by default it is there because it is the iterative statement there. So 13, 14, 19, 20 is the slice. Okay. Similarly, lock is used in the statement number 19, which is the input statement. Okay. So that is the set is 19. So it is defined statement which is included there. Okay. So this is how these are the different sets where you are basically the slices based on the logs variable. Okay. So these are the slices that you can make. Now, given the commission problem, if you remember the commission problem, what is the commission problem? The problem where the particular salesperson go around in the city and sells 3 components of the rifle. Okay. So those 3 components, like lock, stocks, and a barrel, right? So these are the 3 components which the particular person sells, and then depending on the sale amount, the particular salesperson gets the commission. So for $1,000, the particular person gets 10% commission on the sales. For next $800, the person gets 15% commission, and above that, the person gets 20% commission. That is what we discussed, right? So you can see the particular commission problem statements here. This is the commission problem, right? That is, now when you have a program, these are the programs. On the right hand side, we have the statement numbers. We will consider these as the node number while doing the slice. Okay. And then this is here the program ends. Okay. So these are the node numbers. This is the program flow graph for that particular commission problem. Okay. Considering this background, we will discuss in terms of slice. Now coming here, you can see for all the statements or slice that is to be done, that means all the statements where variable appears, right? All the statements where the variable appears are taken out from the program. So the slice one, see this is the single variable slicing. First we will be doing the single variable slicing. Then we will go for the double variable slicing. Then more number of variable slicing. Okay. So double variable slicing is nothing but the union of 2 single variable slicing. So first we will have to identify all the variables, the slicing on the basis of a single variable. Okay. So here all the variables where a particular variable appears. Suppose the stock, see here log price. Log price is defined in 7. So this is one slicing. Similarly, S2 is stock price is defined in 8. So that is one slicing in the statement number 8. Barrel price defined in 9 numbers, statement number 9. So that is S3 set. Okay. So S4 is the slicing. That is, these are the slicing numbers. Okay. So S4 is the set of slicing where it is done on the total logs in the statement number 10. That is the node 10. So S5 is the slicing done on the total stock on the statement 11 or node 11. That way, for all the variables are identified wherever it is used in different statements. Okay. So in total we identify 42 different slices. Okay. See, slice number and the statement number need not be same. They will be different. Okay. Slice number is the continuous sequence number for different slicing of the single variable. Given the nodes here, nodes are on the right hand side. Now here, example commission problem, you see for that defined statement, that is the defined in the node 7 is the set has only one statement, that is the 7, because we are having only definition of the log price. That is the input defined on the, that is assignment defined of the log price. Okay. Similarly, in the statement number 8, it is the stock price which is being defined. Statement number 9 is the barrel price which is defined. Now you see here 7, 8, 9 in the program. Seven, it is through assignment. 45 is assigned to the log price, so it is defined, that is def A, defined by assignment. Similarly, 30 is assigned to stock price in the statement number 8, so it is A def. Okay, and then again the 25 is assigned to barrel price. So these are basically defined by assignments. Okay. Similarly, we will have 3 more definitions here, that is the total logs for total stocks and total barrel through assignment. Okay. And then there is the logs which is a through input. Okay, so all these are, this will be part of. See here, the slice 3, then slice 4 is the total logs, that is the node 10 which is through assignment. You are assigning 0 there to the total logs. Total stock is assigned 0, that is given in the slice 5. Total barrel is assigned 0, that is given in the slice 6. Logs is taken as the input defined in the slice 7. Okay. Then slice 8 is nothing but the part of 13, 14, 19, 20. That is in the previous slide we have already shown that how it has come. Logs used in the 14. Here. Logs used in the 14. We are considering here is part of the loop logs, so it will have where it is defined, that defined statement has to be included. Defined used in the predicate, that is P use, okay, that has to be included. P use has to be included. So 13, 14, and the next is 19 and 20. Whereas we have ignored 16, we have not included 16 because it is not changing the value of logs. So we have ignored that particular statement. So we are including in the set of the slices 13, 14, 19, 20. Okay. So that becomes the slice number 8. Similarly, slice number 9 is stocks, not logs, stocks, right? Stock is basically, it is used in the statement number, this one, 15, right? So you can see again from this definition here, in the 15, is the input statement, stocks. So since it is an input statement, you have to use it, you have to include it. Okay. So, but see, this is part of the loop which is being iterated by the logs. You are checking the condition of the logs. So you must include the 13th statement also, because it is part of the loop. It's part of the predicate, it's a P use, predicate use. So here 13, 14, 15, 19, 20 will be the set, because your input statement you have to include and all other statement that is affecting the values of the input statement. Now how it is including, because this is a part of the loop, right? So it is 13, 14, 19, 20. So it is 13, 14, 15, 19, 20. Similarly, barrel, again 13, 14, 15, 19, 20. For the slice, for the barrel is 13, 14, 15, 19, 20. In the statement number 15, right? Barrel is also taken as the input, right? Stock and barrel, both. So the set is same, slice set is same. Similarly, logs in the 16, log is used in the 16, right? So we'll have to take the 13, 14, 19, 20. Same here as the 14. Okay, 13, 14, 19, 20. Because we will not include 16. 16 because the log variable is not changing. But we'll have to slice because that particular statement has the logs as its part. So we'll have to slice it on that particular statement. Similarly, total logs in the 16 is, how is this value getting affected? This value is getting affected by the 10, 13, 14 total logs, where it is defined in the total logs. For this, we will have to go back to the program to show this. 10, 13, 14, 16, 19, 20. So let us go to the program. See, it is in the total logs is defined by assignment in the 10. 13 we have to include because the log is defined by the variable logs, right? So 10, 13, 14, right? Then the total logs has the logs and the total logs, so 16, right? Then 19 and 20. So which of the values the total logs is affected by? Which values? It is getting affected by, first is the input for assignment, the statement number 10, so 10, node 13, 14, 16, right? Then 19 and 20. Okay. So that is the slicing for the total logs. Similarly, we can have the slicing for stocks in 17. That will come as 13, 14, 15. Because in a 15 we are taking the stocks as the input through input define, okay, IDEF, and then 19, 20. Similarly, total stocks will have those statements because this is total stock is calculated in 17, statement number 17, right? So it will have the statements 11. In the 11 it is being assigned the value 0. So through the IDEF, so sorry, def A. So it is the 11, 13, 14, 15, 17, 19, 20. Okay. Now you see in the total stocks 15 is also included. Why 15 is included here? Because the stock is taken as the input here, which is affecting this particular the value of the total stock. So the 15 also has to be part of the total stock, slice total stock. Okay, that is, so whichever other variable which is affecting this particular variable have to be included. So 15 is included. 17 is where it is being calculated and assigned. So 17 has to be included. 19 and 20 are the part of the loop. So that way the barrel is done, total barrel is done. Okay, in the logs 19, the variable logs in the node 19 that being sliced, okay, that is 13, 14, 19, 20, because there only 19 is taken as the input defined variable. So we'll have to include as the part of the loop 13, 14, 19, 20. So similarly, slices at 18, 19, 20 are output statements. So hence you can ignore it, not include it. Okay. So 18, 19, 20 are the output statements. So you can ignore those statements. That is these are actually OU statements. OUs did not be included. So in the slice 18 is about the total logs in the node number 21. So that will come as the statement as 10, 13, 14, 16, 19, 20. Okay. So let's see about this one. Total logs start from the 10, then 13, 14, right? And when you have the total logs, the 16, right? And the 19, 20, that will come in the total logs part. In the statement number 21, okay? So similarly, total stock in 20 number 22 can be done. Total barrel in 23 can be done. Okay. So slices in 21 through 23 deals with calculation of variable cells. So we can simply calculate as 30. That is the slice 30 with slices in 27, which is nothing but slices in 23 union slices of 26 union slice of 29 union the 27 number. Okay, 27 number basically calculates the total. That is the total cells, right? The variable cells. So we can calculate by taking the union of some slices already done, including the statement number 27 because their cells value is getting affected. After that, we can do all the slicing in the commission problem. As you can go through it, you can just ask me if you have any doubt about those slicing problems here. Okay. Finally, the commission is getting calculated, and these are all the commission variable in the statement number 31 has this number of the nodes in the slice. Similarly, in the statement number 33, this number of nodes in the slice. That way, it is basically having different slices. Okay. So for calculating the total commission. So if you have any doubt, please ask me. Okay. I am always available. You can just ping me and you can ask me whatever doubt you have. Please don't keep quiet and just do not be mute. Okay. Ask, be frank, and please be asked whatever doubt you have in your mind. I am always available. Thank you.